Okay. So we do actually get to see geometry showing up here. And the problem with that is, like on your SAT, you guys, they do not give you these formulas. These formulas we have to know. So honestly, we could probably do even better if we had more problems like this, because they just come out of nowhere through geometry. All right, they did not give me these measurements. That's our x. And what that tells me when I look at this, and I have to kind of step back and look at this entire problem, is basically what we were doing is looking for a way to like figure out that height. We don't know the height of our box. So if you had material and you were building a box, but you're kind of questioning, okay, well, how tall can I make this box? And it doesn't have a top. Because remember, you know, a box has a top, bottom, side, front, back. So we're missing that top, because that would be attached somewhere on the sides here. So we're looking at building a box without a height to it. Okay, the next thing that they gave us was too much information when it came to the length. They told me this whole length is 19 inches, and this entire width was 10 inches. And your number might be different, and that's okay. I'm going to take my time. Please slow me down if I'm going too fast. Because I was like really excited when I figured out how to solve this, that I think I solved it too fast for my first period. Oh, sorry. Okay, so they're giving me the length from here all the way over here, including the x's. Now, one thing that helped me when I solved this problem was I put like a W here and an L here, just because they did tell me what they wanted me to consider length and width. So the 19 went with the length and the 10 went with the width. If they didn't tell me, it wouldn't matter. Okay, length and width is commutative property when we're multiplying. Okay, so that's all the information they gave me in the picture, and I can see that I have a little bit too much information here. That's why we have some x's. And they're asking first to find the length. And this is A. Excuse me. Okay, so the length of my box is dealing with the 19. Okay, so if this is a net where we've taken the sides and we've laid everything down. So I'm just going to look here. From this corner over to this corner is my length. So I know it's 19 for the whole thing, so I need to take away these two x's that it's including. So minus 2x. That's the length of my box. And the best thing about boxes is the front and the back are the same. So the length is 19 minus 2x on mine. So yours will be whatever that total number is they gave you, and we'll have to take away the two x's. Because the box length, when I fold it up, isn't as long as what they're telling us. Okay. Okay, I'm going to turn my paper here. Okay, to find the length, or sorry, the width, that's using the 10. And they told me that the entire thing, listen, the entire thing is 10, but if you notice on the inside, they gave me a little bit too much information. I just need to know from here to here, because that's the width of my box when I fold that up. And when I fold these sides up, they would go away. So it's going to be 10, and I'm going to take away those two x's. And again, the best thing about a box are the two ends are the same, so I can just repeat that down at the bottom. Okay. You sure you don't want to go ask? They might let you go. Yeah, take the sign in front. I'll tell you if it's minus or positive. I have one, but don't tell my sophomores. I don't loan it out to them. I'm punishing him from last year because I had 4 charges and he stole them as freshmen. Okay, now my height. Okay, the height of the box. The height would be from the bottom to the top, right? So that is my x. And you just type those in. The length first. The whole thing?
Yeah.
What happened? Excuse me. Well, hopefully it saved it. Okay. Is everybody caught up on that for your number 8? Volume is length times width times height of a rectangular prism of a box. They don't tell us that on our PSAT. Like, you have to know how to find the volume. And our answer in this case would be inches cubed because it's 3-dimensional, length, width, and height. So it's cubed. If it was area, it would be length and width, and it would be square. But that's how we know. Thank you. Is that this one? Yeah. So you got your number 8? Perfect. And if anybody has their progress reports, I'll take those too. I'll forget to ask. Okay, so now for that, it's going to be 19 minus 2x. Shh, please listen, you guys. I'm recording this so I can use it in the future on this problem. Because it's a stinker. Thank you. Would you just make sure you fill out that form? Because I had someone come looking for a kid in my second period from my first, and I was able to say, oh, it's over there on the rolly cart. And I was able to say, no, it wasn't any of my kids that got in trouble. So I was able to kind of stand up for them. Absolutely. All right, so here we go. I'm just going to multiply. I'm going to be honest. I found that it's easier to just go ahead and get rid of that x just to keep binomials as long as I can. But honestly, it does not matter the order you solve it because it's all commutative property. I just have to make sure I write the right number. So here it would be 10x minus 2x squared. Okay. And then it's over, under. So I get 190. 19 times 10x. Oh, forgot my x. And then 19 times negative 2 is negative 38. X squared. And then negative 2x times 10x is negative 20x squared plus 4x to the third power. Now I will go ahead and change that to standard form. Remember, starting with your, and I can combine like terms, right? Starting with my highest exponent, I get 4x to the third power. Negative 38 minus 2 is negative 40x squared plus 190x. And I'll pause and wait and give you time to work out your volume if you still need help with that. Okay, so a quick correction here. So this should have been 20x squared. And when I combine like terms, I get negative 58x squared. Okay, again, so surface area, volume, those are, believe it or not, like 6th grade standard. So we have to have those memorized. If they're not going to tell us by the time we're juniors, listen, they're not going to tell us those formulas. We have to know them. And they give you a reference sheet, but in my opinion, it's trash. Like it hardly gives you any information. Shh, listen. All right, so to find surface area of a rectangular prism or a box, it's the sum of all surface, how do I say it? Sum of all areas. That's what I'm going to put. And since they're broken into rectangles, that's length times width. Another area formula that they assume you know by now, because I believe that starts in like 2nd grade. Whether it's right or wrong on that, because I feel like you guys nowadays are in the world that you can always look things up, I kind of think they should give you more because you don't necessarily have to have it memorized as much because you can always Google it, right? So, I mean, I think in time things will change for you guys, but it hasn't yet. It hasn't for you at least. So we do have to have those things memorized. And it is kind of like common sense, like common knowledge that everybody kind of knows in the whole world. So no areas, length times width, surface area is the area of all the surfaces. Okay, so to write those, I am going to come up here. And now I'm going to be honest, I'm regretting writing this on the inside of my shape. So I'm going to take a step back here. And I'm going to say this is my length. And I know to find length and width, I would multiply this by x. Because I like my area inside. Perimeter's outside, and that's when we add our lengths and widths. So I'm going to adjust my picture here just so it makes a little more sense. So again, this is the length from here to here. And then to find the area, it would be length times width. And our width is that height of x. And the best thing about a box is if you know the area of one side of the back, you know the area of the front. And we're just going to take those areas and add those. So down below here, I am going to say, okay, I have 19 minus 2x times x plus 19 minus 2x plus x. I have that twice because that's surface area. Right, now I have the area of the back and the front. And I'll add those. Okay, back here, I'm going to turn it again. And let me clean this up. I should have, in my first period, I wrote it right. I should have written this above here to say that's the width. Listen. And when I do area, it would be length times width. And again, I always like to write area on the inside because area is the area inside of our two-dimensional shape. So our area is 10 minus 2x, the length, times another x, the width of each of those boxes. And again, the best thing about it is if you know one end, you know the other end because the box is the same. So I would add 10 minus 2x times that extra x plus 10 minus 2x times the extra x. What do you need to do? What do you need? So we have the front, the back, side, side. And now we only need the bottom because, again, this box doesn't have a top. It doesn't have that sixth side. So all rectangles makes it easy, length times width. So the length of this box is from this corner to this corner, which is the same as this corner to this corner. So it's 19 minus 2x, and I'm going to multiply that by this corner to this corner, which is 10 minus 2x. Because it doesn't include those extra x's there. It's just length times width. So I'll kind of highlight it with this orange. It's this length times this width. So down here, plus 19 minus 2x times 10 minus 2x. And we get this giant expression, which actually cleans up really nicely. Like, it looks crazy right now, but it cleans up really nicely. I'm going to distribute my x's. And honestly, I'm going to do that all the way across. This is the third time I've worked this problem out, and it just seemed easier to do that. And then I can go ahead and put my over, under here. I'm just skipping this line to give me some room to show those arrows. Okay, so 19x minus 2x squared plus 19x minus 2x squared plus 10x minus 2x squared plus 10x minus 2x squared. Now I'm going to do my over, under. 190 minus, I forgot what 19 times 2 is. Keeping the sign, that's a negative 2, so 19 times negative 2 is negative 38. Keep the x. Now underneath, negative 20x plus 4x squared. Whew. That looks insane, but it actually cleans up nice for my surface area. Might not look like it right now. Now it's combining like terms. I'm going to go ahead and start in standard form, so I'm going to start with my highest exponent. So I get negative 2x squared, negative 2x squared, negative 2x squared, 2x squared. That is not a square. This is why I like to use color pencils when I'm color coding, because I can erase them if I make a silly mistake. And again, take the signs in front. So negative 2, minus 2, minus 2, minus 2, plus 4. I get negative 4x squared. And I know some of you might be looking at that saying, look, if it was really the surface area of a regular box, I would not have an x, right? We would have a real number. So this is the algebra part in our geometry. In real world, we would be either finding the value of x, or we would already know the value of x, and we could just go back and plug that in. So I know that this looks like a crazy answer, and if I went to like Home Depot and was like, hey, I'm building a box with a surface area of this, you know, of negative 4x squared, they're going to look at me like I'm insane. Just know, you know, realistically, there's going to be a little bit more to it. We're just building you these skills up here, those process skills on memorizing the formulas and knowing when and how to use them. Still throwing in our algebra standards. So all my x's cancel. I got 0. So that means I don't have to write anything. Excuse me. And then I've got my loner constant right there of plus 90. 190. So again, I'm aware, I'm with you on that that looks like a crazy surface area problem and does not feel like it's real world. And it's not right now. But the process is, the knowing when to use surface area, how to use surface area is real. We just have to also have those algebra skills. What we could do here is either be looking for the value of x, or, which remember is our height. We might just be trying to build a box with materials we already have, and we're just going to determine, okay, if this is what I have, how tall can I make it? It's okay to have an unknown, and we can solve for that later.